question. Where did the law of sines come from? So the law of sines is this very beautiful formula used to solve oblique triangles. Sine of A over A equals the sine of B over B equals the sine of C over C, whereby a simple proportion we can solve for sides and angles of oblique triangles. But where exactly did we get the formula from? So to show you, I have an oblique triangle. So I have an oblique triangle, I have angles labeled capital A, capital B, capital C, and I'm going to label the sides opposite of those angles as little a, opposite big A, little b, opposite big B, and little c, opposite big C. And since the law of sines is based off sine, and sine is a trigonometric function, a trigonometric ratio, and trigonometry is fundamentally based on right triangles, even though we can use it in a unit circle, but even when doing unit circle trig, it's based off right triangles with inside that circle. What we're going to do is we're going to find a right triangle from this oblique triangle. And so we can get that by slicing and dicing. So I'm going to slice this guy like so. And when I slice it and dice it, I have this right triangle. I have two right triangles. And I have this distance. So this distance is perpendicular to the base of the triangle. And so that's typically called the height. So I'm going to call it the height. Now notice with angle A, the height is opposite angle A, and the height is also opposite angle B. So since this is called the law of sines, let me do the sine ratio for angle A and for angle B, and let's see what happens. So sine is opposite over hypotenuse, so the sine of angle A would be h over B. So the sine of angle A would be h over B, which means if I was to solve this for h, I would multiply by B, which means h is B sine A. If I do a similar deal for angle B, the sine of angle B is opposite over hypotenuse, so the sine of angle B would be h over A. And if I was to solve this for h, I would multiply by A, which means h would be A times the sine of B. So you have two expressions here, where h is B times the sine of A, and h is A times the sine of B. And one thing we know, if we don't know anything, we know that h must equal h. So therefore, if h equals h, then that means that B times the sine of A must equal A. This is A times the sine of B. This is sine B here. Slight typo there. Must equal A times the sine of B. So here's a fact here. And everything is good, except it's not as aesthetically pleasing as it needs to be. Like I have a B with an A and an A with a B. Why not have A with A and B with B? So I prefer for this B not to be on this side. So I'm going to divide by B. But if I divide by B on this side, I got to divide by B on that side, which is fine because it puts B with B. But similarly, I have this A over here. I don't want this A over here. So I'm going to divide by A. And if I divide by A on this side, I have to divide by A on this side, which is perfectly fine because that'll give me A with A. So what happens when we do this division by AB on both sides, here B cancels, here A cancels, and we have the sine of A over A equals the sine of B over B. Again, my capital letters are angles. My lowercase letters are sides. But it doesn't give us the whole picture because the law of sines says the sine of A over A equals the sine of B over B equals the sine of C over C. And here I have no reference to C. And the reason I don't have C here is because I chopped C up. C was the actual angle that I sliced and diced. So just a miniature picture of the triangle that I used. It looks something like this. And I did my chop here, so I chopped up angle C. So I'm going to use the same triangle, and I'm just going to chop up an angle other than C and see what happens. So if you will, I'm going to rotate the triangle a little bit. So I'm going to rotate it where the base is now B and C and A is on top. So it'll look something like this. So I'm just rotating. So this is the exact same triangle I used a minute ago, but I'm rotating now, and now this is B and this is C and this is now A. And so I'll do the same thing as before. I'll create a right triangle. And again, this is little b here, this is little c, and this is little a. Now, this is the height of the triangle with this perspective, but it's not h. It's not equal to that other height. Even though this is the height of the triangle, this triangle has a different base. So now the base is BC. So this length is not equal to the h as before, unless it was an equilateral triangle. And we're not saying the triangle is equilateral. So I can't call this distance h. So let's say I call it k. But so side k is opposite of angle B and angle C. And so we're going to do similar as we did before. I'll find a sine of angle B, and the sine of angle B would be k over c, which means k is c sine B. And I'll find the sine of angle C. The sine of angle C would be k over B. The sine of angle C would be k over B, which means k is B times the sine of C. So k is C times the sine of B, and k is B times the sine of C. And if I don't know anything, I know that k should equal k. So that means that C times the sine of B must equal B times the sine of C. And you know, I prefer this not to look like this, so I'm going to divide both sides by BC. So I'm dividing both sides by BC, and here the C would cancel, and here the B would cancel. And from that, we get that the sine of B over B equals the sine of C over C, but we already determined that the sine of B over B is equal to the sine of A over A. So in total, the sine of A over A is equal to the sine of B over B, which equals the sine of C over C, and that is how we get the law of sines.